guys, I am Melody Sernel and Bersola, and I am the next reporter for the chapter 8. So when we say Euler path, what is Euler path? It was or it uses every edge of connected graph exactly once. So ginagamit niya lahat ng graph, dinadaan niya lahat ng edge ng graph. Then it starts to one graph and it ends to the different graph na. Halimbawa, unang graph mo is A. Then, next niya or mag-end siya sa letter D. So, hindi na siya bumalik. So, yun yung Euler paths. While Euler circuit, same naman siya dun sa Euler path na dinadaanan niya lahat ng edges pero bumabalik siya dun kung saan siya nag-start. Halimbawa, nag-start siya sa A, babalik siya sa start sa pagka-end. Papakita ko sa inyo yung example ng Euler paths. Next,
ito example niya guys. Dinodrawing ko pa. Ano to? Euler path siya. Euler paths. So, ano napapansin nyo? Diba yan? Graph yan. So, one Euler path for this above ay ang unang galaw niya is sa F papuntang A. Yung A, next naman dyan, pag next path niya is papuntang B. So, ito, lalagyan yung line, arrow yan. Then, after that, yung B, mapupunta sa C. Yan, di ba? Dinadaanan niya lahat ng path. So, after ng C, babalik siya ulit sa F. Yan, next, pag bumalik siya ng F, yung F, mapupunta siya sa C, ay sa E. Ayan. Diba? Wala na siyang dinaanan na nagamit na. Lahat yun unused. Or di pa nagamit na path. Next ng E is dadaan ka na naman dun sa E to C. Ayan. E to C. After that, yung C is mapupunta na naman siya sa D. Then, mapupunta siya sa, and after nun, D to E naman. So, ano napansin niyo? Sa Euler path, diba, sabi ko is, magi-start siya sa, isang vertex na yan, pero, magi-end siya sa different. Kasi diba, sa iba, ang niyan, ang pagkakasusunod niyan is F, A, B, C, F, E, C, D, and E. Nakita niyo naman, di ba? Ayan siya. Ayan yung pagkakasunod-sunod and ayan yung nasa graph na, di ba? Okay. Next naman is buray muna natin sila. Yan, buray natin. So, next is the Euler circuit. So, ang Euler circuit, sabi ko nga, diba, na kailangan is hindi siya hindi siya magdi-different paths pag nag-ends. Dapat babalik siya sa kung saan siya nag-umpisa, dun din dapat yung end niya. So, ito yung example niyan. Dito siya ang starting point natin. Yan. Starting point natin. Yan. So, ito yung gagawin natin. From E to A. Then, A to B. Then, B to F. Then, pupunta siya ulit ng then, F to E. Then, E to F ulit. Then, bababa siya sa D. Then, pagkababa ng D, D to C naman. So, C, next is C to E. O, diba? Bumalik siya. Kung saan siya nag-start, doon din siya mag-end. Yan. Yan ang Euler circuit. Ito ang pagkakaano niyan. E, A, B, F, E, F, D, C, then E. Kung ano yung start niya, yun din yung end niya. Gets?
The Fourier's algorithm. Next is the Fourier's algorithm. It is the useful way to find the Euler path or Euler circuit in a graph. Ito yung mga steps. First is verify the graph is connected and that all of its vertices are even. Number 2, choose any vertex to start at. So, mamimili tayo kung saan tayo gusto natin mag-start. Next is travel along the edges, making sure that whenever possible, some edge is used that would result in an unused part of the graph. Become disconnected, or continue traveling along edges until all of the edges are used. The circuit will have returned to the vertex where it started. So, bibigyan ko ulit kayo ng example.
Ito yung example. Mag-i-start tayo ngayon sa E. Yan ang starting point natin. Then, the trail could use either EF or EC at this point. This is the example. We will use the edge EF. So, mapupunta siya sa EF dito. Ayan. And after that, the second edge will be the FB. FB. Ito naman. F to B. Ayan. Hindi siya pantay. Yan. Euler circuit siya. Then, next edge circuit is to B to C. Yan. Papunta dyan. Next is the edge 4 will go to CA. Dito. Ayan. Ayan, babalik na siya dyan. Then next is A to F. A to F. Yan, babalik siya dyan. Then after that, mapupunta naman tong last, from F to B, F to D. Then, next is, D to C. Then, yun nga, sabi kong circuit, babalik siya sa same vertex kung saan ka nagsimula. So, C to E. Ayan. Gets na siya. Okay?
Okay. Next is the Chinese Postman problem. The Chinese Postman problem formulated and studied in 1960 by Guan Liu. So, ito yung parang kasabihan niya. He was to start and ends at the same points or dun nga sa post office. Then, he needs to go through every state. Diba kailangan isa-isahin yung mga parang post office o yung mga nag-deliver kada street. Yung mga letter, diba, ibibigay yun. So, bibigyan ko ulit kayo ng example kung paano ba nagagawa yun. Or paano ba yun.
So this is the example of the Chinese Postman problem. So, in the step 1, list all the odd vertices. List all the odd vertices. Yun yung A, B, C, and D. Then, the step 2 is list down the possible pairings. So, ang possible pairings niyan is A, B, and CD, AD and BC. Next is AEC and BED. Ayan yung mga possible pairings niya, di ba? And after that, pag nakuha na natin yung mga possible pairings, next natin is find the weight sum of each pairing. So, yung ano muna unahin natin, yung first pair muna, yung A, B, and CD. So, ano ba yun? AB, which is ito din ito, is ito. So, bale, 6 plus CD, which is ito, then ito yun. Ayan yun. 6 is equals to 12. Tandaan natin yan ha. Ang nakuha natin is 12 for the first pair natin. Next pair naman tayo. The AD and BC, which is the AD natin is 4 plus BC is 9 is equals to 13. Kung kanina sa first pair natin is 12, dito naman is 13. Kasi kinuha natin yung BC, then yung, no. Ito, yan. Nalilito na ako. So, next pair natin, last pair natin is AEC and BED, which is yung AEC natin is A, itong A, then yung ito. Kukuhain natin yan kasi nag-pass through siya, di ba? A, tas yung ano na E, then C. So, 8. Ganun din, BED, kuha natin yung 5, then yung 3 ng no. So, magiging 8 equals to 16. So, nakuha na natin yung weight ng tatlo. 12, 13, and 16. So, next is the minimum weight sum of the pairings determine the edges to be added to the original graph. Or yung original graph. The original graph dyan, yung 6 plus 6, diba? Nag-ano lang siya yan, mag-kaumpisa yan. The minimum weight is 12. Yan ang minimum weight. Yan ang minimum weight. And lastly, i-add naman natin yung lahat yan, lahat ng nandito sa graph na yan. So, 6 plus 9 plus 6 plus 4 plus 3 plus 5 plus 3 plus 5 is equals to 41. Next is, after this procedure, move on tayo to number 6, which is kuhain naman natin yung or ipagpa-plus na natin yung optimal Chinese postman, which is yung total nung sum of all weights, which is yung 41 plus yung sa kanina na 12 equals to 53. So, ayan na yung optimal Chinese postman, 53. So, parang magiging ganito yan. Dagdagan natin siya na dito. 6. So, itong magiging ano yan. From D to A, ayan. Then, A to B, B to C, C to D, then D to E, then E to B, then babalik B to A, then A to E, then E to C, the next is C to D. Ganyan ang magiging mangyayari. Diba dinaanan niya lahat? Yun nga yung sabi dun ni Guanig, yun na he needs to go through every street. So, walang napalagpas dyan, diba? Lahat napuntahan niya.
So next is the Hamiltonian path and Hamiltonian circuit. So Hamiltonian path, same as Euler path, it uses every vertex in a graph exactly once. Yun nga, ginagamit every graph ng isang beses lang. And it starts and it ends at the different vertices. The graph is considered traceable. So balik katulad ng vision ng Euler, paano siyang kuhain na mag-i-start siya sa isang graph or dun sa isang vertices, pero mag-i-end siya sa different vertices. Halimbawa, nag-start ka sa A, mag-i-end siya sa E. Next is the Hamiltonian circuit. Same as Euler circuits, it uses every vertex of the graph only once. Ganun din. Isa lang, isang beses lang ginagamit. It starts and ends at the same vertex. It is also called the Hamiltonian circuit. Cycle. Ganun din, nag-start siya sa isang vertex na letter B, mag-end siya sa letter E. Ganun. Hindi na siya magdi-different paths or different graph or vertex na yan. Yun. Ganun lang pagkukuhain yung Hamiltonian path and Hamiltonian circuit. Same as Euler path and Euler circuits. Next is the Hamiltonian graph, a graph with more than one vertex, and that which has a Hamiltonian cycle is a Hamiltonian graph. Hamilton cycle are named after Sir William Hamilton, an Irish mathematician who invented the puzzle called Gaussian game. The puzzle consists of a regular dodecahedron, 12-sided geometric ball, with the whole of each of the 20 vertices. Each side or faces is a regular pentagon or 5-sided figure. Yan. So, ipapakita ko na sa example. Ipapakilala ko na example sa inyo.
So, this is the example. Diba? Ganyan. So, paano ito mangyayari? Paano mangyayari yun? Paano mangyayari yung pag-cycle niyan? So, mapupunta siya. Unang step dyan is A to C. Ayan yung magiging unang starting point, okay? Number 1 yan. So, after that, mapupunta siya sa A to D. The next is D to B naman. And next is B to A. Diba? Cycle na siya. Graph na tawag dyan. So, pwede din naman siyang mag-start dito. Start siya sa D, papuntang A. Ay, papuntang B. Ayan. Next is B to A. Next is A to C naman. Ganun lang din nangyari, pero ibang way naman siya dumaan. Diba? Ganyan lang ang Hamilton graph. So, pag ganito, anong tawag sa kanya? Diba? Ano siya? Hamilton path. Yung unang ginawa natin is Hamilton circuit. Kasi nag-start siya dito, And nag-end siya dito rin. Pero dito, nag-start siya sa D, pero nag-end siya sa C. So, dito siya matatawag na Hamilton circuit. Hamilton patch siya. Okay?
Okay, next is the Dirac's theorem. For connected graphs, G with no multiple edges and n vertices, n is less than equal to 3 is if every vertex has degree that is less than equal to n over 2 or vertices over 2, then the graph is Hamiltonian. Hamiltonian means it has a Hamiltonian circuit. This theorem is sufficient condition for circuit, not necessary condition for Hamiltonian graphs. So, mag-give ulit tayo ng example.
Okay, yan na example yan. Sorry So, above is one of the most used figure in graph theory. The Petersen graph. It was constructed in 1898 by Julius Petersen. Yan yung Petersen graph. This graph has 10 vertices. 10 vertices. Vertices, yan. Vertices. So, done. And di ba sabi ko sa'yo, n is equals to 2 or is equals to, ano natin, 10 over 2. So, pag pinag-divide yan, magiging 5, di ba? After natin makuha yan, para makuha yung, yun nakuha natin yung equal niya. Each of the vertices of the graph is of degree 3, which is not or less than equal to 5. Kasi mababa pa. Hence, by Dirac theorem, Petersen graph is not Hamiltonian. Yan. For any complete graph, or K, an optimal Hamiltonian circuit or cycle in weighted graph can be determined by using algorithm, one of which is the greedy algorithm. In this algorithm, one has always choose the cheapest option or the one that the lowest weight until every one of the vertices has been transversed. Yan ang Dirac's theorem.
Next is the algorithm. Ito yung mga steps niya. One is choose any vertex as the start point. Pipili na lang tayo. Then, select from the edges connected to it and one with the lowest weight or pinakamababa. When there are two more edges having the lowest weight, choose any one of them. Next is from the end vertex of the selected edge, choose the edge with the lowest weight. Continue to the process until each vertex has been transversed. For 3, return to the start point or vertex.
So, we will use the Dirac's theorem as an example. So this we will use the n is equals to 4 because it has 4 sides. 1, 2, 3, 4. Then the degree of each vertex is 3. Yan. So, pag na-distribute natin is n is equals to 4 over 2 or 2. Then after that, the degree of each vertex is 3. Is 3. 3 is the greater. Yan, greater than to 2. Greater than the value of 2. Mas mataas siya, di ba? Mas mataas siya. So, 3 possible Hamiltonian circuit of cycles since NHC or the Hamiltonian circuit or cycle is equals to 4 minus 1 2 is equals to 3. Ay, wait lang. So, in using greedy algorithm by starting from the vertex A, here, the vertex A, choose edge AC, which is ito then ito. From C, take the edge of CD. Then D, take the edge of DB. Then, from B back to A. So, kaya naging siyang Hamiltonian circuit or cycle. Kasi bumalik siya dun sa starting point niya. And yun din yung naging end point niya. Yun lang po. Next reporter na po. Thank you.
Number of possible Hamiltonian cycle for complete graph K with n vertices less than equal to 3. The permutation of this number is n. Since every vertex is counted n times in the permutation divided by n, so that n divided by n is equals to n minus 1. Yan. A cycle can go two direction, clockwise or counterclockwise. Hence, the number of possible Hamiltonian cycles and Hamiltonian cycles for a graph with n vertices is determined as follows. So, magiging siya, number of vertices or number of Hamiltonian cycle is equals to n minus 1 over 2. Yan. So, try ko mag-give ng example.
For network theory, it is the study of graphs as representation of relations between discrete objects. Such relations can either be symmetric or asymmetric. So dito, pinapakita, pwedeng possible na A is equals to B, and which means B is equals to A. Then pwede din namang A is greater than B or B is greater than A. Pwede din A is greater than or equal to B. Ganun. It could be symmetric nga or asymmetric. So yung network daw referred to is to us a graph whereby the vertices or edges or both have attributes like names, qualities, features, etc. One of the areas of network theory considered for this course is network optimization, which is a topic under combinatorial optimization. This involves finding an optimal object from a finite set of objects. It is a part of mathematical optimization and in the study of operations research and computational complex theory. Among common problems in combinatorial optimization are the minimum spanning tree (MST) and the traveling salesman problem (TSP). Now for minimum spanning tree. A graph is a tree if and only if it is connected and does not have a cycle in it. A tree must have at least two vertices of degree, one or at least two edges with one of their vertices not connected to another vertex. In general, if the number of vertices of a tree is n, it must have an n minus 1 edges. A collection of trees is called a forest. Kung mapapansin nyo dito, may mga point A, B, C, D, E, and F. Tapos dito naman A, B, C. Same points, pero iba-iba yung pagkakakonect sa kanila. So kung mapapansin mo dito, connect lang, isang linya lang yung connection nila. Then ito, magkakakonect sila pero naka-isolate sa C. And dito naman, merong nabubuong cycle. So ito, Dahil meron siyang nabuong cycle, ito, magkakonect si A at B, si B and C, and si C and A. Ang sabi dito is, a graph is a tree if and only if it is connected and does not have a cycle in it. So ito, hindi siya considered as a tree. So ito naman, hindi rin pwede kasi naka-isolate si C, hindi siya naka-connect. So itong graph 1, ang example ng tree. So ito naman yung itsura niya kapag pinag-connect ng points. And yun. Circuit rank is the minimum number of edges that must be removed from a graph so as to eliminate all cycles in the graph. If m is the number of edges of the graph and n is the number of vertices and y, comma, is the circuit rank, then y is equals to m minus open parenthesis n is minus 1 and close parenthesis. Now, under Cayley's theorem, makikita dito yung figure na to, triangle, and the graph has circuit rank y, wait, wala mo siya itong i-explain dito, pero ito, the three spanning trees are shown in figure 8.8. Each spanning tree is obtained by deleting or removing one edge from the complete graph. So, dito, for 3 points lang na pinag-connect with different angles. Minimum spanning tree is a balanced tree of a graph with at least some of the edge weights. These are algorithms for finding a minimum spanning tree for weighted graph. Only the Kruskal algorithm and Grimm's algorithm will be discussed here. They are both referred as Wheatley's algorithms, as every stage of the selection process involves the cheapest or the one with the least weight. Both algorithms can be used to find a spanning tree in a graph that includes every vertex of that graph, such the total weight of the edges and the spanning tree is minimized. The difference between the two is the selection of the first vertex. So for Kurzweil's algorithm, starts with a vertex whose edge formed with another vertex that has at least the least weight. Mark this edge. Cross to another edge with the next lowest weight, but making sure that the selected edge will not form a cycle in the graph. It does not go to the next edge with the lowest weight, and mark this edge. Continue with the process until and so on and so forth. Notes: if a vertex leads to two or more edges of the same weight, choose any of the edges, making sure no cycle will be formed and that the next edge will have the lowest weight. In Kruskal's algorithm was formulated in 1956 by Joseph Kruskal and first appeared in Proceedings of the American Mathematical Society. Prim's algorithm. So, and here, if a vertex connects two or more edges of the same weight, randomly choose any of the edges and mark this edge and the end vertex. Prim's algorithm is named after Robert C. Prim, who rediscovered and republished the algorithm in 1957. It was republished also by Edger, I don't know how to pronounce, 1959. The algorithm was originally developed in 1930 by Wojtek Jamik and such mathematician. For these reasons, the algorithm is also referred as Prim's-Jamik's algorithm, Prim's-Dijkstra algorithm. Okay. Matrix and graph. Graphs can be represented using matrices and vice versa. For an undirected graph to be presented in Table 4, the adjacency matrix can be used. For a weighted graph, the weight matrix can be used. Some refer to this as the distance matrix. Adjacency matrix is a collection of numbers representing the number of edges between vertices. Okay, here is the table. This one. Weight matrix is a collection of numbers representing the weights of edges. It should be understood that the weights could represent distance, cost, time, and etc. Traveling salesman problem. The history of the traveling salesman problem began in 1800s, and its origin as mathematical problem is attributed to Irish mathematician Sir William R. Hamilton and British mathematician Thomas P. Kirkman. Different methods of solution were explored by mathematicians from the 1950s up until the 1980s with the use of computer. The salesman, starting from the place of origin, said his office has to visit K. Say this once and go back to his office. TSB is about finding the shortest Hamiltonian cycle in a complete graph A. Recall that the tour or cycle must start at the end and end at the same vertex. Okay. Brute force method. One of the methods to solve TSB is by listing down all the possible Hamiltonian cycles and computing at fixed time for cost or weight by adding up all the numbers assigned to the edges through which the cycle or tour is completed, provided every vertex is included. Such method is referred to brute force method.
Okay, so good day. I'm Kyle for the traveling salesman problem or the TSP. Based on the history of the traveling salesman problem, it begins in the 18th, and its origin as a mathematical problem is attributed to Irish mathematician, which is Sir William R. Hamilton, and a British mathematician, Thomas P. Kirkman. Okay, so there are different methods of solution were explored by mathematicians from the 1950s up until the 1980s with the use of computer. And the salesman, starting from a place of origin, let's say that his office has to visit the K, which cities once and go back to his office. So we will have an example later para mas ma-clarify natin what is the TSP. Okay. So, yung TSP lang naman, it involves the distances between the cities, no? Dito, inaalam sa TSP, yung possible na, yung mga shortest possible route distances ng mga cities. Okay. So, dito, aalamin natin or magsasolve tayo kung paano natin, kung anong daan ang pwede nating daanan. Kumbaga, saan yung mas may mabilis na daanan. Okay, so we have to calculate the distances, no, from kung saan tayo nagsimula and saan yung destination natin. So for the brute force method, one of the methods to solve the TSP is by listing down all the possible Hamiltonian cycles. So sa Hamiltonian cycles, andito yung kung saan tayo yung starting point and then kung saan tayo susunod na pupunta hanggang sa pinaka-destination natin. Yun yung sa tinutukoy dito sa brute force. Sa brute force method, well, pinadali niya lang naman, no? Kung saan simplest method. Sa brute force method, no, it is an also algorithmic problem that tasks with finding the shortest route between the set points kung saan ka nagsimula and sa location or sa destination na pupuntahan mo. Okay, so let's have here the example. So James has to make a product presentation at 4 prospective companies. Okay, so to introduce their new product. Okay. He has to cover all four companies that day, allowing himself to spend an equal number of time in each company and to report back at the office by the end of the day. So, sinasabi dito sa example is, uh, James needs to make a product presentation sa 4 na kumpanya. So, meron lang siyang limited time which he needed to set a schedule, no? Siyempre, magkakalayo-layo yung mga companies. So, he needs to think kung ano kung saan or ano yung mga fastest na way para mas makarating siya doon sa kanyang pupuntahan and ma-achieve niya yung kanyang time na nilaan sa 4 na pupuntahan niyang kumpanya para sa natatapos na kanyang oras, no, is magawa or matapos na lahat ng kanyang kailangan na gagawin. So below is the matrix he prepared to indicate travel time between destinations, including his office, okay, as his starting point, and end point is yung makabalik siya sa kanyang office and he already make a product presentation sa 4 na kumpanyang iyon. Okay, so we have here the table. Sa table muna tayo. So first, we have to construct a graph to represent the data from the matrix. Since there are 5 vertices for the graph, which must be a complete graph, you can use the figure below. So 5 vertices, sa una, sa kanyang office, of course, yung 4 ng kumpanya. And syempre, babalik siya. Okay, so from here, makikita natin sa table, 0 at 0. No? 0 from company A, company B, company C, company D. Okay, so sa starting point, okay, 0, magmumula siya dito. Ito yung kanyang office. And then kay company A, okay, nandito siya. And then kay company B, okay, dito siya. Kay company C, which is the 72, okay, dito siya. And kay company D ng 48, okay. So, how about naman kay company A, pag nagmula siya? Kay company A, babalik siya kay, ito yung kanyang starting point, mula siya kay company A, and then, okay, company A, no? Yan. And then, papunta siya kay company B, kay company C, okay, kay company D, okay. How about kay company B? Okay, dito tayo muna, papunta siya kay sa company A, okay, and then babalik siya, and then kay company C, okay, dito yan. How about kay company D? 25. Since that we already construct a graph, how about we use the brute force method? Enumerate the route James has to take and determine the least time period. Okay, so the number of possible Hamiltonian cycles can be determined as follows. So ito yung ating equation, which the n, or yung ating hinahanap, no? The route ni James that he has to take, and to determine the least time required using the Hamiltonian cycles is equal to 5 minus 1 over 2 is equal to 4 divided by 2 is equal to 12. So, meron tayong 5 vertices and nagmula siya sa starting point niya and we have to divide it by 2. So, 5 minus 1 is 4 and divided sa ating over 2 and we will get the 4, the 12. So, ang symbol na to is factorial. So, ano nilang dalawa. So, for the next step, we have to enumerate in table 8.3 the 12 possible Hamiltonian cycles of James. So, take note that clockwise order of the vertices is just the same as taking them in the counterclockwise order. So, from the starting point, company A, B, C, D, and back sa starting point, no? We have 30 plus 20, okay, starting point, company A, company B, company C, company D, and ito yung total travel time in minutes, okay, in order. So, how about kapag mula tayo sa ating starting point, papunta kay company A and B, pero nauna si company D kaysa kay company C, and babalik tayo sa office, we'll get the 35 as a starting point, 20, syempre galing tayo kay A, company A. Okay. Okay, yan. So, the distances between the starting point and A is only 5. Okay. So, 35 plus 20, yung distances nila, no? 15 kay company B. Okay, so, paano naging 15? Okay, company B at C. Okay, yung distances nila. So, base yan sa ating graph. Okay, plus 25 plus 72 is equal to 167. So, gamit ang Hamiltonian cycles, no, yung kanilang distances is mako-compute na natin. Using, syempre mag-base tayo sa ating graph. Okay. So, ganun lang naman siya. So, from the table above, it can be seen that the root of starting point and from company A hanggang sa makarating kay company D at makabalik sa office, it will incur the least time of travel for James to cover all 4 companies and get back to the office at a total of 160 minutes. Okay? Ito yung pinaka-ano kasi, di ba? Isa-isa niya yung company and babalik siya sa office niya. On the other hand, the route of starting point, from starting point, pupunta tayo kay company B, kay company B, and kay company D, kay A and C, hanggang sa makabalik tayo sa office, will consume the most time at 245 minutes. Alright. So the brute force method is optimal but not efficient due to the numerous possibilities. So the process is very diffuse as the number of vertices increases. So with the use of the TSP, no, calculating the distances from the starting point to your destination will help you to get there and achieve your time, no, to finish your task. Okay, so for the nearest neighbor algorithm, so one of the earliest methods of solution to TSP is the nearest neighbor algorithm. So hindi lang brute force method ang meron sa TSP, we also have the nearest neighbor algorithm, which is the NNA. The salesman can start at any city, but he has to go back to the same city after visiting each and every city. So always taking the shortest route or going to the nearest neighbor as he travels. So this algorithm is similar to the greedy algorithm in the previous section, no? Kung matatandaan nyo sa taas. So except that it must be a cycle in TSP. So these are the algorithm steps, simple steps. First one, we have to select any arbitrary vertex as starting point or vertex and choosing the shortest edge from the starting vertex and mark starting vertex, the edge, which is the edge, and the end vertex. So from the first end vertex, choose the shortest edge from it and marks it end vertex. So repeat this process until every vertex is marked and that the last vertex is the first vertex selected. Okay, so halimbawa na ito. Okay. So apply the TSP to the problem from example 1. Using the NNA, we mark the route following the algorithm. So here's our graph shown here. Okay. So the sequence of vertex and edge determines the route to take. So this method is so much easier to implement than the brute force method, but this may not always provide the optimal solution, just like in the brute force method. Of course, no? From the table, you see that the root of starting point of A, B, B, C, and go back to the starting point, we'll have a travel time of 167 minutes, di ba? Dito as we go back here. Alright, yan. Okay. Okay. So this is longer by 7 minutes compared to the one obtained using the brute force method, which only contains of 160 minutes. So the solution to TSP using the brute force method is not efficient but optimal, while yung solution sa TSP using this method, which is the nearest neighbor algorithm, is efficient but not optimal most of the time. Okay? So, madaling salita, no, ito yung easiest method, no, to get the solution on your problem regarding sa distances ng iyong location na yung destination na iyong pupuntahan at babalikan. Yung time travel na mako-consume mo using this method. While hindi naman siya optimal most of the time, unlike sa brute force method, no? Hindi siya ganun kasimple, unlike dito sa method na to. But, it is optimal. So, ang pinagkaiba lang nila, di ba, sa TSP using the brute force method, maraming proseso, no? Marami, kumbaga kinakalikot mo yung mga possible route na pwedeng daanan mo and ma-calculate mo na exactly yung iyong oras, no? Papunta sa iyong destination, no? But it will ensure you na ito yung most effective method that you will choose to use instead na nearest neighbor algorithm. So that's all lang naman. So for the summary, here's the summary of the chapter 8. No, we already discussing the graph theory types of graphs. No, meron tayo niyang ilang graph, 13 graph. We already discussed the Euler path and Euler circuit of Miss Melanie Bersola. And dito sa intro natin ng chapter 8, which is the graphs, kay Mr. Obemio. And of course, so for this chapter of network theory hanggang sa ating matrix graph, okay, we have Miss Mendoza. So, thank you to everyone for your time and effort para panoorin tong chapter 8, which is the nature of graphs and networks, and also especially thanks to those nakasama ko dito mag-report and sa mga members ko. That's all. Thank you.